Hello and welcome. I am Daniel, a current Cal Poly Pomona master's student. I work with Dr. Thomas Osberger in the research area of medicinal chemistry. Today I'm going to be showing and explaining the procedure with the reaction of a Grignard reagent with a ketone. Hope you enjoy. To begin, let me review the general Grignard reaction being performed. The first step of the reaction is to combine the ketone and the Grignard reagent, forming an alkoxide. Since various ketones and Grignard reagents can be used, I am showing R groups, signifying other possible carbon substituents. The second step of the reaction is to quench the alkoxide mixture with hydrogen chloride, or HCl. This forms the product being a tertiary alcohol with the added R group from the Grignard reagent. The Grignard reaction shown in this video will be using 3-oxocyclobutane 1-carboxylic acid as the ketone and phenyl magnesium chloride as the Grignard reagent. The products formed in this video will be 3-methyl 3-phenyl cyclobutane 1-carboxylic acid diastereomers. The round bottom flask, stir bar, needles, and addition funnel need to be clean and water-free. We use an oven to dry our glassware, but other methods of drying glassware can be used per other reaction conditions. The next preliminary step is making a nitrogen-filled balloon. This will be used to mitigate moisture contamination within our round bottom flask and addition funnel apparatus. Begin by first inserting the needle into the rubber septa. Next, turn the black knob upward to open the nitrogen outlet. Then plug the glass opening to fill the balloon with nitrogen gas. The balloon will be used during the first reaction of the ketone and Grignard reagent. To begin the reaction setup, pour reagent alcohol into an empty ice bath reservoir and start cooling the alcohol. We use a Nestlab CryoCool CC65 immersion cooler that chills the reagent alcohol to roughly -43 degrees Celsius. Exact temperature for cooling and method of cooling can vary per experiment conditions. Make sure to place the ice bath reservoir on top of a stir plate. This will help eliminate having to rearrange the reaction setup later. After placing the coil into the reagent alcohol, the next step will be to set up a thermometer to monitor the solution throughout the reaction. Make sure that the thermometer goes inside the solution of reagent alcohol to get an accurate estimate of temperature. While waiting for the ice bath to chill to -43 degrees Celsius, we can remove the round bottom flask and stir bar from the oven. And we will place it in a desiccator to cool to room temperature. Next, while the glassware is cooling, the appropriate mass of starting material will be measured out, making sure to tar the weigh boat before adding the starting material. For this procedure, I'm using 1 gram of starting material, which is the 3-oxocyclobutane 1-carboxylic acid. Once the round bottom flask and stir bar are at room temperature, the starting material can be added. Now that the starting material is in the round bottom flask, the addition funnel can be attached to the round bottom flask. Make sure to use oven gloves when handling the hot glassware. Next, Close off the system using a rubber septa. Make sure to shove the septa all the way down the opening of the addition funnel and make sure to pull the flaps of the septum funnel over the top, covering the system. At this time, the addition funnel and round bottom flask apparatus are vacuumed down for 5 minutes to remove the air in the system. This is done by turning the black knob downward to vacuum out the air. After the 5 minutes, the air is refilled with just nitrogen gas. This process of vacuuming and refilling with nitrogen will be repeated for a total of 3 times. Once that is completed, you will leave the balloon in the septa. Now that the system is under nitrogen atmospheric conditions, we can add in our solvent to the addition funnel. To begin extracting solvent from the solvent bank reservoir, open the top black knob. This will create a small gap for the needle to fit through. Next, insert the needle into the reb septa, making sure the needle goes all the way into the solvent. Make sure the needle is attached firmly to the syringe. Next, start extracting the solvent by pulling the syringe plunge outward. After extracting the appropriate amount of solvent, remove the needle from the solvent, making sure to fill the top of the syringe with the argon gas. This will make sure that no moisture comes in contact with the solvent. Note that the solvent being used here is free of water for better product yield. Now, insert the needle into the rubber septa and fill the addition funnel. Make sure the needle goes all the way into the addition funnel and begin filling the addition funnel reservoir. Make sure the stopcock on the addition funnel is in the closed position when adding the solvent. Remove the needle from the addition funnel septa. Next, we could open the stopcock, adding the solvent into the round bottom flask. Make sure when you add the solvent into the round bottom flask, the flask is not inside the chilling solution, but rather at room temperature, or as you can see here, resting above the chilling solution. After adding the solvent and starting material together, make sure the starting material is completely dissolved. After the starting material is fully dissolved, drop the round bottom flask into the chilling solution. While the solvent and starting material are cooling, the Grignard reagent can be added to the addition funnel. First, insert a nitrogen balloon into the septic covering of the Grignard reagent bottle. Next, insert the syringe needle into the top of the septa and begin extracting the appropriate amount of reagent for the experiment. When transferring to the addition funnel, make sure to fill the syringe with some nitrogen gas. Insert the syringe needle through the top of the septa of the addition funnel. Make sure to insert the needle several inches into the addition funnel. Add in the Grignard reagent and make sure the stopcock is in the closed position. To initiate the reaction, slowly open the stopcock of the addition funnel and add the Grignard reagent over 30 minutes. Make sure the stir bar is stirring throughout the whole addition. Once all the Grignard reagent has been added, make sure to turn off the chilling instrument and gently remove the coil from the chilling solution. Leave the reaction stirring at room temperature overnight. After the reaction has been stirring overnight, the second step, quenching with HCl, can occur. First, cool the reaction using an ice bath. Once cooled, add 10 milliliters of 2 molar HCl into the addition funnel with the stopcock in the closed position. The septa and nitrogen balloon can be removed at this time. Now with the HCl in the addition funnel, slowly add the HCl over 30 minutes with the solution stirring. After the 10 milliliters of HCl is added, check the pH of the solution. The pH range should be between 0 and 1. Check the pH by inserting a glass rod into the reaction solution and transfer the solution to a pH paper. The pH can be checked several times at different depths of the solution. If the pH was not in the 0 to 1 range, add more HCl using a pipette. Make sure to check the pH after every addition. Now with the reaction at the appropriate pH, let it stir at room temperature for 45 minutes. After the 40 minutes of mixing, the product is extracted 3 times using ethyl acetate and 1 time using brine. The aqueous and organic layers are separated, and the organic layer is dried using sodium sulfate. The product is transferred to a round bottom flask and rotovaped down. Thanks for watching.